multiplying your polynomial. This is important because eventually you're going to do this backwards. So pay attention to how you do this. All right, example 1. The typical one that everybody understands how to do is the monomial.
All right.
Here's a monomial multiplied by a trinomial. Okay, so everybody should know how to do this, but we're going to go through it just to make sure before we do anything more difficult. Are we ready? First thing, you got to distribute everything that's out here to every term inside. So 3 times 2 is? And what's x squared times x squared? Yeah, you add your exponents. We have a plus sign, so 3 times 4 is? And x squared times x?
X cubed.
X cubed. It's a 1 on that x. Minus sign, 3 times 5, 15, and x squared times x to the 0 is x squared. The last part everybody needs to make sure they understand. Okay, everybody understand that that's still just x squared? Anybody not understand that, raise your hand.
So like with 3x times 3x squared times 3x to the negative second would be 9.
Yes, it would be 9.
Okay.
Okay, everybody got that? Eventually you're going to do this backwards, but not today. You're going to be given this answer, I'm going to ask you what's common in all terms. Take that back down to the outside of the parentheses, and instead of multiplying, you divide it. So we'll do that another day. Yeah, that's cool. All right, binomials. A binomial times a trinomial. So here it is, 2x minus 4 in parentheses. In the other parentheses, x squared minus 4x plus 3. So instead of working up to this, I thought I'd jump in and just kind of explain exactly what you do. It doesn't matter how many terms are in the left side. It doesn't matter how many terms are in the right side expression. What matters is how do you multiply these two parentheses together. Remember what I say. You take every term inside the left parentheses, each term, and distribute it to each term in the right parentheses. So, what's important here is the minus sign. You need to understand that this is negative 4. Okay? Don't distribute 4. Even though that's positive 4, really this is plus negative 4, right? Alright. So right now I'm just going to focus on this one. And I'm going to distribute to each term here. 2x times x squared.
2x to the third.
2x to the third. That's right. 2 times 1 is 2. X to the first times x squared is x cubed. Anybody lost? I can write it out a little bit more if you need it. Alright. Now, this is a good reason why I don't ever do subtraction. Because now you have a 2x, you have a minus 4x. What operation goes here? Some students really don't know. Some of you might think it's really obvious. But there are students that really don't get what you're supposed to put down here. So, if you're one of those students, this is what you should do before you start doing these operations. Go through and change everything. And that way, if you change everything, it'll always be a plus sign between all your terms. So you don't ever have to question. Now, you go 2x times negative 4x. What's 2 times negative 4? Negative 8. And what's x to the first times x to the first? X squared. Good. And we have another plus sign. Now 2x times 3? 6x. Now you're not done. That was the first term. Now you got to do the second term. Distribute the negative 4 to each term in the second parentheses. And if there were 3 terms, you'd then do the third term. Okay? So, negative 4 times x squared. What? Negative 4x squared. If you want to write it like that, that's fine. You can put plus negative 4x squared. That's okay. Everybody in here is supposed to know that those two are the same thing. Okay? Now, negative 4 times the negative 4x. Yep, negative times the negative is positive 16x. And a negative 4 times a positive 3. Negative 12. And I don't care if you write it as plus negative or just minus 12. Either one. Everybody in here better know that those are the same thing. Alright, you're not done. You gotta put like terms together. What's the highest term? 3. The 3. So that's first. There's no other cubes there, so 2x cubed is first. What's after that?
2.
The squares. A negative 8 and a negative 4. It's negative 12. X squared. Now I have a 6x and a 16x. 22x. And then you have a minus 12 left over?
Yeah.
Okay, wait, I don't need that other thing anymore then, because that was the question. I didn't know how to combine like terms.
Oh, okay.
I didn't know if you added them together or you had to add the x's together.
When you're adding, you don't change the x or the exponent. Because it's how many of those you have. How many x squareds do I have? A negative 8 and a negative 4. I'm not multiplying them. So if I take, just for instance, if I take negative 8x squared times 4x squared, really what I have is negative 8 times negative 4 times x times x times x times x. Is that true? Which is positive 32 x to the 4.
Like I don't think I was sure what 3x times 3x.
But a negative 8x squared plus negative 4x squared, how many x squareds do I have? It's a negative 8 plus a negative 4. I have negative 12x squared. When you're adding and subtracting, it's how many of those things do you have. When you're multiplying and divide, you're multiplying everything. Okay? All right, example 3. And that's extremely important. Those are great questions. We need to make sure that we have that mastered before we take the end of the course assessment, all right? Okay, so I gave you the hard one first. We're going to do this next thing called FOIL. The only reason I'm telling you this is because it's been around forever and they want you to use it, I guess. Yes?
I know what it stands
What's it stand for?
for. First, outer, inner left.
First, outside,
Oh,
inside, and last. I assume most of your parents will remember the word FOIL. They may not remember how to do it, but you don't need to know it because you already know how to do this. So it only works with 2 binomials. So we're going to do 2 binomials here. We'll do x plus 2 and 2x minus 4. The first thing I want you to do is I actually want you to figure this out based on what we did in example 2. Everybody work on that. And then I'll show you what FOIL is. Again, if you need change your subtraction signs, do so. If you don't, then don't. Ready? Over here we're finishing up. Now, this is really probably the most important example in this chapter, because what you're going to be doing in the last half of the chapter is doing this backwards. We usually do that with two binomials. We don't do stuff like this. You get into cubes and stuff like that in Algebra 2. But in Algebra 1, in Chapter 9, this is the main focus. Okay, so you're going to learn to do this backwards, and you're going to learn to do what we're doing here backwards. So let's do it forward first. Now, you did it the way we did it here. I'm going to do it with FOIL. FOIL means the first two things are multiplied together. X times 2x is 2x squared, which is what everybody did first. The next thing is outside. You're supposed to do the outside of the 2. So these two are the outsides. X and minus 4. Minus 4x, right? And didn't you do that? Yeah. Okay, then you have the insides. The inside would be these two. 2 times 2x is 4x. Well, didn't you do that third? Right? Yes or no?
Yeah.
And then you have the last two things. 2 times minus 4 is minus 8. Isn't that what you did? You already did FOIL based on just understanding how to multiply multiple terms together. But that's what FOIL means, because you might actually see that on the main test where it says use FOIL to do this. Well, if you do it this way, you're going to do FOIL no matter what. It doesn't matter how you do it, you're going to get the same. You better get the same answer. Okay, so these two go together. That's 0, right? Negative 4x, I mean, remember you're adding.
Oh, yeah.
Okay. So now you have 2x squared minus 8. And you're going to learn how to do this backwards later on. That was example 3. Last example. Example 4. Find the area of the shaded region. Was this the shaded region, Luke, was this one of the questions you had on the previous? Was it the shaded area part? Was that one of your questions or not? You remember?
The first, I had a question about the perimeter of shape, yeah. But
Oh, the
that
perimeter?
wasn't what I was, that wasn't what the question was even about. My question was about how you divide the terms at the end.
Okay. And you're good now?
Yeah.
You think you're okay, all right. So here it is. You have a big rectangle. It is 4x plus 2 by x squared minus 1. And there's this little rectangle inside. It is 2x by x. I want the shaded region. How do I do this problem, first of all? Luke.
You gotta find the area, the big one, and then you gotta find the area, the small one, and you subtract the small one.
Yeah, because you're cutting out the small one. Cutting out means you're subtracting. So the area of 1 minus the area of the smaller one. Okay? Everybody know what to do? Yes. Yeah.
Didn't you just set it up like two binomials and subtract them? The outside, in parentheses, subtracted by the little. Kind of, but you got to do this binomial here. You
you have to do this first. You have to get the area of this big part first. All right. So the area of the first one is base 4x plus 2 times x squared minus 1. That's the area of the larger rectangle. Then we're going to subtract this area, base times height. Who set it up correctly? Ouch. Okay. Everybody figure that out, and then I'm going to do it on the board and see if you got it right. Did it right? Who did it right? Yeah, some of you are still looking. That's good. Awesome. You guys ready?
Wait. What about the plus 2x squared?
That's a positive 2, that's a negative 2.
How'd you get that?
Yes.
How'd you get that last part?
2x squared minus 2x squared.
Oh, I did the first part first and then
They still get the same rates.
Oh,
Okay.
and you add that last. You
And
gotta do that.
subtract that area off, the second area.
Yeah. I haven't done that.
Okay, page 565. Okay, listen carefully. I don't want you to read the instructions. Does everybody hear me?
Yes.
Yeah.
I want you to look at the problem and do what I've taught you to do. Don't read your instructions. Okay? Alright. Page 565. 4 to 48 evens. Mixture view evens. Don't